In this video, let us review the concepts of using versus proving, and do that through the example of talking about how to use an if-then statement and how to prove an if-then statement, which we'll review those things along the way. Now, there are statements in the process of proof in general. Confusingly, there's the step of proving something and the step of using something. So using means you already know something is true, or you get to assume something is true, and then how do you get some further facts from that? Versus proving, which means here's a statement and you'd like to know whether it's true or not, and maybe you think it's true or you've been told to show that it's true, and so then you're providing a solid argument for why that should be. The thing about using versus proving is that they're always done differently. So let's look at this in the context of if blah then blah, if P then Q. So what is it? First of all, what the heck does if P then Q even mean? That's going to be important to figure out first. So this just means, so if this entire sentence, if P then Q, that entire thing, for that to be true, it means that in a situation where P is true, Q must be true. There's no other possibility. And so that's summarized in this truth table. So if P is true, then Q must be true. Okay, but so we can't have the P being true combination together with Q being false. Now, if P happens to be false, then all bets are off, right? So we can say if P then Q is true, it doesn't matter the truth value of Q, whether Q is true or false, in the situation when P happens to be false. The only thing we're not allowing to happen is the combination of P being true while Q being false. Okay, so that's what if P then Q means, and based on what if P then Q means, we should talk about using if P then Q versus proving if P then Q. Now, using a statement and proving a statement always look very different. That's true for an if then, that's true for an and statement, that's true for an or statement, that's true for a for all, that's true for a there exists. It's always the case. So you should always look at the statement you have and ask, do I need to use it? Do I need to prove it? So again, proving a statement means to provide an argument. Following mathematical standards, that the statement that you're trying to prove is true, and using a statement means to start from the situation of just saying that that statement is true, and then gaining a new truth out of it. That new thing that you get is called a conclusion. So how do you prove if P then Q? Well, let's say it sort of depends, but most of the time, 90% of the time, what you do is that you assume that P is true. So the text that appears right after the word if and right before the word then, you just assume that that's true. So you're going to live in this imaginary parallel world where P happens to be true. And then based on having P being true, then you work to prove that Q is true. Now, how you prove that Q is true is very problem specific, but it's going to, have to involve something based on the specifics of what P assumed to be true was. Okay, so that happens most of the time. The remaining 10% ish of the time where other things happen, we're not going to cover that right here. Now, how do you use if P then Q? So assuming that you already, again, and this is not what happens all the time, but most of the time this is what you do. So this is summarized visually in this format. So if P then Q is true, then and you also know that P is true, then you can combine both of these things together. So this if P then Q combined with just P, if you know P is true, then the two things combine so that you can conclude that Q is true. Now this isn't always done, but that's what happens most of the time. Again, using versus proving are very different. They look very different here. And the thing is, if you need to prove if P then Q, but you try to use if P then Q instead, you'll get stuck. Same, if you flip the word prove and use here, here, and here, the same problem occurs. So if you need to use if P then Q, but you try to prove if P then Q, then you're going to get stuck automatically every time.